Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 6 of the 30-day LeetCode challenge, and the problem which has been given to us is the group anagrams problem. This is a pretty straightforward problem, so let's just dive right into the problem description. So you've been given an array of strings or words where you need to group all the anagrams together. So you've been given an input over here and you need to just group all the anagrams together. And if you don't know what an anagram is, basically a word would be an anagram of another word if they have the same character count. Well, that's basically the idea behind this thing. So you can see that 8 and eat are anagrams of each other because they can be transformed into each other. Pretty straightforward, and you've been given a few notes over here which are important to note, which I'll sort of discuss why they are so important in the uh, next part of the video. But the inputs which have been given to us are all lowercase, so do remember that, and the order of the output does not really matter, so that's also awesome. um, and yeah, and whenever you try to solve this problem, the basic intuition behind this thing is that you want to use something like dictionaries, where you can use the key as the sorted value of whatever word that you're getting, and the value would be a list of whatever word that you have. And what that would do in our case would be that if you have eat, tea, and ate, well, the sorted value of these words is AET, right? So that would be our key, and the values would be eat, then t would also have the same key, so that's going to get appended, so that's going to be t, and then 8 is also going to be the same thing, so that's also going to get appended to our list. Pretty straightforward, so let's just code this thing out. So you will start with your base condition, which is that hey, if no strings have been given to you, then return nothing, and you would need a a dictionary, and I'm using a default dictionary so I don't get any key errors, and you can see that I'm passing in list so that the value is always going to be a list. And yeah, that's basically the intuition behind how you would structure your data structure. And all you need to do is you need to iterate through each word in your strings list, and you would want to maintain a sorted value of the word. So let's just do that. Let's do sorted word. Um, and this is going to be s. This is going to return an object to us, so we can just convert it to a tuple because tuples are hashable. And all you need to do now is just use result s, which is the sorted word, as the key, and append whatever word that you have. And if you sort of have a print, you can see that you'll get a dictionary structure which has the key, which is AET, which is a sorted, tuple in our case, and the lists of all the anagrams grouped together. And to return the values, you just need to do return values, which is going to return all the values, which is going to be a list, and this is going to be a list of lists. So let's just go ahead and submit this code. Hopefully this should run fine and there should not be any issues. So you can see it's been accepted, and that's great. But there is a gotcha over here, which most people don't really realize. Um, and in interviews also, people have a, I mean, most of you would have realized that whenever you have an interview, people would ask you what the time complexity is. And the time complexity over here is n into k log k. And k log k is happening because of, okay, so k is basically the character length or the word length. And when you sort of look at that, this sorted operation happening within a for loop is not really the most optimal way of doing this thing. But the idea behind this thing is still in the same direction, that you want to get a sorted, well, not a sorted way, but additionally get the character count. So what I'm trying to get at is that you can try to solve this problem at a much better time complexity, which is n into k. And the way you can do that is by leveraging the note which has been given to you, which is that all inputs will be in lowercase. And you can assume that there are not going to be any special characters either. If you do that, then what you can do is you can create a character count array and then sort of store all the counts of the characters of a particular word, make it into a tuple so it's hashable, and just push that in. And the data structure still remains the same. Just instead of doing a sort operation, you're just updating another character count operation. So let's do that. So we'll say character count, and we're going to use a list comprehension here so that we have a list which is ranging from 0 to 25, which is basically A to Z, which is 26, right? And all you're trying to do is you'll update the character count, and the 0th index is going to be denoted as character A, index 1 is going to be denoted as character B, and so on and so forth, right? And all you want to do now is you just want to do a simple for loop, which is for ch in Word, because you need to iterate through each character and just update the character count. So character count can be updated pretty easily, but do remember that this is a string in essence. So you need to use something called as ORD, or you can use something called as string dot lowercase dot find, which is another operation inside the string library. But I like the ORD way better because it sort of shows that you know about ASCII characters and all that stuff. So when you do ORD and ORDCH, which is this CH, and you subtract that with ORDA, ORDA is basically going to return the ASCII value of what lowercase a is, which is 97. And whatever operation that you get, if you get Z over here, well, if you subtract the value, you're going to get 25, which is what you want. If you have A over here to the highlighted portion, that's going to be 97, and you're going to do 97 minus 97, which is 0, and we know that the 0th index is sort of determining the A value. So that's the entire intuition behind how you would go about it. It's pretty straightforward. So you have this character count, and at the very end, you just need to convert it to a tuple so that it can be hashable and pass it to your result. That's just like a small change, and you can see that the solution has been accepted. And let's just go ahead and submit this once again, so that we know everything's working fine. And awesome, it is working fine. And this is the more optimal solution. This is still running at a complexity, time complexity of at least n cross a. Um, the k is happening because you're iterating through each character in the word. And from the space complexity standpoint, this is still n cross k because you have this dictionary which has a key, which has all the values, which is also a list, and so on and so forth. But if you don't solve this problem in this way, well, when your interviewer sort of tells you to optimize the problem, you're going to get stuck. So that's basically it for today's video. It's a pretty straightforward problem, and it has a lot of solutions to it. If you don't really care about time complexity, you can do it the sorting sort of a way, which most people do. But I like this way better because then you have control over a lot of things, and then you sort of show the interviewer a lot of things like, hey, I do understand ASCII characters, I do understand hashable sets, and so on and so forth. So that's just my personal opinion, but you guys can do you. So that's basically it for today's video. If you do have some comments or there was some doubts that you had, do leave it in the comment section below. I try to respond to all my comments as soon as I can. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you, and stay at home.